The Physics of Equestrian Vaulting, presented by Zita Saunders
and Sophie Jacobson.
Do you know what I've always wanted to learn about?
No, what is it?
Well, the physics of equestrian vaulting, of course.
Oh wow, that's a great question. Shall we look into it together?
Yes.
When I think of physics, do you know what I think of first? Newton and his laws.
I bet that Newton's third law applies to vaulting.
I bet you're right. Let's watch a video of a vaulter on a horse and see if we can spot Newton's third law.
You know what? I noticed the force of the horse on the vaulter was equal to the opposite force of the vaulter on the horse.
Absolutely right. I bet that we can write an equation for that. Let's start by calculating the force of the earth on the vaulter, so then we can find out how much force the vaulter pushes down onto the horse. The vaulter has a mass of 54.4 kilograms. That means the force of the earth on the object is negative 533.12 newtons. Since the vaulter is sitting directly on the horse, this is how much force she applies onto the horse.
Right, and since it's in Newton's third law relationship, the force of the horse on the vaulter will be opposite the force of the vaulter on the horse.
That is perfect. When we put that into Newton's third law, we can 533.12 newtons equals negative 533.12 newtons.
Amazing! Looks like it's confirmed that Newton's third law applies to vaulting.
Let's find what the force of gravity is on the horse.
Good idea. I know that Alfie has a mass of 680 kilograms, so we just need to multiply that by negative 9.8 newtons per kilogram. So after we do that, we find that Alfie weighs 6,664 newtons.
That is super cool. You know what I just thought of? There are times when the vaulter is not on Alfie's back, and she has to land on him. How does that work?
I'm pretty sure that has to do with momentum, impulse, and the sum of forces. I know that when a vaulter does a jump move, she has to take this into account. Look closely and you can see that she bends her knees when landing. A big part of this move is momentum and how to stop it safely for the horse. The momentum equation is momentum equals mass times velocity. We know that the vaulter has a mass of 54.4 kilograms. The velocity is distance over time. The vaulter's velocity is 2.03 meters per second. Now we can calculate momentum. The vaulter's momentum is 110.06 kilograms meters per second.
Wow, and if you remember that she has to land on a horse, that surely will be putting a lot of force onto Alfie's back, won't it?
Yes, you're right. That is where the sum of forces has to be considered. If the vaulter were to land her jump with straight legs and not absorb, her impact time would be extremely quick and make the force she lands with greater. Without bending her legs to lessen the impact time, the vaulter applies negative 1,104.32 newtons of force onto the horse's back at the time of impact.
I know that the vaulter cannot change her mass or the change in velocity to lessen the sum of forces on Alfie's back, but is it possible to change the time of impact?
It sure is.
If the vaulter had simply taken 0.3 seconds to land rather than 0.1, the sum of forces at the moment of landing would only be negative 368.11 newtons.
I wonder how that changes the impulse.
Let's check. The equation for impulse is impulse equals the sum of forces times the change in time. Would you look at that? Since impulse is the change in momentum and each scenario has the same change in momentum, the impulse is the same.
Oh yes, very true. I bet that Newton's first law applies to vaulting, don't you?
I bet it does. Let's take a look at a scenario and see if we can find how Newton's first law applies.
Wow, look at how the vaulter falls at a constant speed once the horse leaves from under her. That looks like Newton's first law.
You're so right. Here, when the horse initially starts running, you can see that friction holds the vaulter's knees to the pad.
Great observation, but we can see that after the horse leaves from under her knees, she falls at a constant speed.
Yes, Sophie was in motion, then fell in motion at a constant speed.
Okay, well what about center of mass? What is it and how does it relate to vaulting?
I am so glad you asked. For the human, the center of mass is in the hips, and for the horse, the center of mass is over the spine. Keeping these two things in mind helps the vaulter stay stable during tricks, and it is necessary to put in specific areas to execute some moves.
Oh, cool, I totally get what you mean now. The center of mass is in relation to your balance, so you don't go flying when you're on the horse.
Exactly. It's one of the core fundamentals in the physics of equestrian vaulting. Since the center of mass is normally around the hips, Sophie keeps her hips situated vertically in line with the handles and moves the rest of her body around that location to stay in balance and in control.
Awesome.
Is there anything else you'd like to know?
No.
I hope you learned a lot today.
Cool, I want to learn how to vault now.
Yay. Thank you for watching.
Thank you for watching.